We're going to next learn about the unique function, which, for all intents and purposes, is a unique function. So, a little wordplay there. Hopefully everybody gets it, and hopefully everybody kind of chuckles at it, because I chuckle to myself. Yes, I know I'm a nerd. Alright, so what the unique function does is it pulls out all of the duplicates. So, I'm going to give you a scenario here. And this is a scenario that Mr. Johnson, I got to give credit where credit's due. I asked him, I said, hey, I need a scenario to be able to use this unique function, and he gave me this one. So there's actually different feed bunks that they use in feedlots, cattle feedlots, where as the cow walks up or the calf walks up to feed out of the feed bunk, it will weigh the feed, the amount of feed prior to the feed stepping on, or the calf stepping on the scale, and after. So it automatically detects how much that calf is eating. And it's also reading their RFID tag that's in their ear. So now you're getting a bunch of data points showing how much these calves are eating throughout every single day, and it's keeping an accurate track of it. But also whenever those calves step on that scale, it's also weighing those animals. So how many times do an animal go to a feed bunk? Probably several times throughout the day. So what I did was I said, all right, I want to come up with this is the order in which those calves or those cows are going up to the feed bunk throughout the day. And this is the amount that every time they step on the scale, that's how much they weigh. Well, we're probably not going to be so much concerned with every single time they step on the scale, but probably the first time of the day that they step on the scale. That's where our parameter is going to be. So if we look through here, we can see that number one stepped on the scale here and then stepped on the scale here. Well, and this is 275 or 274, and this one is, 672 and then 674. Well, we don't really want the second number. We want the first time they step on that scale. So we want to remove this number. This one, maybe that calf went and laid down in the mud and rolled around in the mud and gained a couple extra pounds because of the mud. Well, we don't really want that. We just want the first time. So what we're going to do is we're going to use this unique function right here. We're going to use this unique, and it's going to remove all of the duplicates. And that's what the unique does. It says returns a unique row in the provided source range, discarding duplicates. Rows are returned in the order in which they first appear in the source range. So we're going to go through and we're just going to highlight all of this range. And as you can see, we have quite a few data points. We have quite a few times that these animals have walked up to the feed bunk. So we highlight that whole column, press unique, press enter, and we see that, yeah, we might have had close to way down here into the 100th row, we had almost 100 data points, but yet we only have a handful of animals that actually walked up to the feed bunk. Matter of fact, we're going to use a previous formula that you have already learned to figure out exactly how many animals have walked up to the feed bunk. We have 23 animals that are in this pen, but yet we have over 100 data points. We don't really need that many data points, or we don't really need all that. So we just use a unique, and it removes the duplicates, but it keeps it in the order in which it first appears. So we see that 13 appears first, then 7, then 4, then 1, 3, 2, 6, 11. Then all of a sudden it skips this 1. And what I'm doing is I'm looking right here and comparing this column to this column. We get to right here, and all of a sudden the 1 disappears, but we jump to 25. Then the next 1 is gone, but we jump to 17. Then 16, then 9, then 10, then 19. Skip the second 19. We go right to 15, to where what it's doing, all it's really doing is just removing the duplicates. Now, a lot of these formulas can be used in conjunction with each other, or used with another one. So if you remember back to assignment 16, you used an if-then statement, and inside that if-then statement had a is and a formula, and in that is and a was a VLOOKUP, followed by another VLOOKUP later, and we're using these formulas together. That's kind of the way this Google Sheets and Excel are designed to do. So we're going to use formulas with each other, and I often use formulas with each other, such as that count the function alongside this unique function to figure out exactly how many animals were in this pen. So here I'm going to use a VLOOKUP, because what we are doing is we already have their animals, the animals in which the order they came to the feed bunk. Now I want to pull across the corresponding weights of each animal. So if you remember how to use VLOOKUP, we're going to look up first that search key, all of our data, which this is going to be all of our data points. I'm going to just highlight all of that, lock it in because it doesn't change. Our index is we are looking to find the weight off of each animal. So the index is going to be in column 2. And of course, our is sorted is always going to be false. So what that does is we said we want to go in there and I want you to find, we're telling the computer, go into this data set, find the first time that it says 13 and bring it across this column, which it did. It's 650. We can drag that formula all the way down and we can see at the first time number 7 came up, weighed 674. First time number 4 came up, weighed 675, and so on and so forth. The number 1 came in, he weighed 672. He came in later and weighed 674, but we're not recording that. We're only recording the 672 the first time he came to the feed bunk. Number 3, first time he came in was 650. If we go down here to number 19, first time number 19 came in was 687, and so on and so forth. So we're going to use that equals unique to remove the duplicates. Then we use that VLOOKUP to find the corresponding weights of each one. And then we could use maybe that SUMIF function to figure out how many, or maybe not a SUMIF function, but maybe we're going to use the COUNTIF. COUNTIF function to figure out how many of these weigh above say 675. We find that 5 of them weigh above 675. So then we can use those formulas all together to kind of start making more robust and find our data a little bit easier. So let me give you another scenario where the unique might come in handy. Imagine you are you have a large cattle ranch, or maybe you have a large operation of any kind, and you're going to sell, or you have an auction, or maybe you have a fundraiser, or you have something going on every year that you send out a bunch of letters. For example, here at Casper College, we have the annual lamb and pig sale coming up in April, or that is held in April of every year. In that lamb and pig sale, we send out notifications to previous buyers and potential buyers, and we have a long mailing list, and that mailing list might be 200 or 300 people. And if we are constantly trying to update that mailing list, it could be very easy if we have 200 and 300 people lined up in that mailing list to duplicate somebody. Well, if we're duplicating somebody and we're just simply printing off all these envelopes using another computer program, then all those that are duplicates, we send those same letters to the same people 2 or 3 times because we've inputted their data more than once. Or imagine that you're on an operation where you're sending out flyers for an annual bull sale, and every year you collect all of the potential buyers' addresses or all the buyers' addresses that showed up, and you want to make sure and you just add that to the bottom of your mailing list every year to make sure you've got everybody. But pretty soon you've got the same person 5 or 6 times. Well, we can use that equals unique to pull out all of the duplicated names. So here we have a list of, say, potential buyers. And if you look through here, we have myself, Mr. Jones, Mr. Johnson, Dr. Burkett, Mr. Horniker, John Smith, and Adam Smith are both in there. We have Jane Doe, and then there's my name again. But if we had 300 names, it could be kind of difficult to sort through here. Here we only have about 20 names, which makes it easy to sort through. But if that was the case, if we had 300 names, we could use the unique function to have it do it for us, to have it isolate and tell us what are all of the non-duplicated ones. And out of this list of 20 names, we see that we duplicated 3 names. So that's whenever they show up blanks down here, it means that we duplicated 3 names. And those names I duplicated were, first, my name. I duplicated Mr. Horniker's name. And then, who was the last one that I duplicated? Might take me just a quick second. And see, I even created this, and it's still kind of hard for me to figure out exactly which one I duplicated. So what happens is we can use this unique to take the guesswork out of it and just have it come up with the correct answer right away. So I paused the video so I could look real quick, and now I'm back, and I wanted to figure out what that third name was that I duplicated. And I went through and I had to actually kind of manually search for it, and I can see that the last one I duplicated was this Jane Doe. So if you ever do have these duplicates and you're wondering, man, who did I duplicate? Who is the one that I need to figure out who I duplicated? What you can do is you can just start comparing the two lists. So you can see that this one's in order, this one's in order, this one's in order. All of these are in order so far. And then all of a sudden we get down here, and while these are in order, I'm actually going to unbold these to make it a little bit easier to see. We come down here and Jane Doe's in order, then all of a sudden these are no longer in order. Well, that means that it removed my name from this list, the second of my name, the duplicate of my name, and it shifted everything up one. So now this one should correspond with this, and it does. These two correspond. And while these two should correspond, they don't. Well, why is that? Well, here's our second duplicate. So it removed that from this list over here. So now we know that this one should correspond down here, which it does. This one should correspond with that one, but it doesn't. So now we know that this is our third duplicate. So that kind of helps identify maybe who is the duplicated name in that list.